Hi folks, in this video we will begin to talk about how to display and organize data using tables and graphs. Part of the reason we're spending some time on this topic is that graphs can be very powerful, for better or for worse. Let me give you an example of this. There was an experiment done a few years ago where half of the people in this experiment were given the following paragraph to read about the effectiveness of a new drug. And you'll see if you read this paragraph that it says that this drug has been tested and it dropped cases of the common cold by 40%, from 87% to 47%. And after people read this paragraph, they were asked whether they believed that this drug was truly effective. The other half of the sample of the participants who completed this study read the same paragraph, but accompanied with a bar graph that looks like this one. Now, you'll notice the bar graph doesn't really add any new information whatsoever to what's already written in the paragraph. All it does is it takes that 87 and 47% and shows them as two bars on the graph, but it doesn't provide any new information. So in this experiment, the independent variable, in other words, the thing that the researcher had control over, was whether the people in the study either saw just the paragraph or the same paragraph with the graph accompanying it. The dependent variable was their answer to the question, do you think that this drug is effective? Now, you might be surprised to learn that even though they were given pretty much the exact same information, the people who saw the graph thought the drug to be more effective. 97% of those people thought that the drug was effective. Whereas if they didn't see the graph and only got the paragraph, only 68% of them thought the drug was effective. So graphs can be very persuasive because they look official, they look scientific. They look like, the person knows what they're talking about. So even if the graph doesn't really contain any useful information, it can still make that information have more of an impact on the person reading it. Graphs are also helpful in terms of organizing large amounts of data. So this is the example we're going to work through for the first bit of this video today. Imagine I gave my class an exam. There are 50 students in my class. Remember that we use the capital letter N to indicate how many people are in our sample. In this case, we have N equals 50 students, and these are their scores in no particular order. Now, if I just were to give you this mess of data, 50 exam scores, you probably can't do a lot with this information, right? You can look around and say, okay, it looks like, there were a good number of B's, there were a good number of A's, I see 1 or 2 C's, I don't see anything below a 70. But you have to do a lot of work to kind of make sense of this information. So the question is, how can we make this easier? How can we make this information more digestible for the person who wants to understand it? One simple solution would be to do what's called a frequency table. So with a frequency table, what we're doing is we're taking each possible score and we're showing the number of people who got that particular score. So if we were to take the same 50 exam scores that were shown on the previous slide and put them into a frequency table, the frequency table would look like this. Now imagine this as one big table. I had to cut it off into two because of the limitations of PowerPoint. But we have one column for grade, meaning those are all the possible scores that people could get. Everything from the lowest score, which was 77, up to the highest score, which was 98. Next to that, we have a little F for each of those scores. That F stands for frequency, and it tells us how many people in the class got that particular score. So, for example, 2 out of those 50 students got 77s, 1 person got a 78, 2 people got 79s, and so on and so on and so on, all the way up to 1 person who got a score of 98 on the exam. This makes it a lot easier to see a couple of things. First, we can easily tell what the highest and lowest scores in the class were, right? The lowest score was a 77, and there were 2 people that got that score. The highest score was a 98, and there was 1 person who got that score. We don't need to include rows for scores that didn't actually happen, right? So there'd be no point in putting rows for 76, 75, 74, and so on, because no one got scores that were that low. This also allows us to find the most common scores. So 4 people got 85s, 4 people got 86s, 4 people got 88s, 4 people got 89s, 4 people got 91s, and 4 people got 92s. So it also starts to give us a sense of what the average score might be, right? It looks like most students in this class got somewhere between a B and an A minus. So we might guess that the average is about a B plus in this sample. But obviously the scores were also really spread out, with some people getting C's and some people getting A's or even an A plus. Another thing that the frequency table allows us to do is to determine the percentage of people who got any given score. So if we know how many total people were in our sample, we can easily calculate the percentage of people who got any given score. In this case, for example, we know that there were 50 students in the class. 2 of them got 77s. So if we divide 2 over 50, that's 4%. In other words, 4% of our class got 77s. We could also maybe combine categories, right? So there were 2 77s, 1 78, and 2 79s. If we add those together, 5 students got C's on the test. 5 out of 50 is 10%, so we could say that 10% of the class got C's on this exam. Now, this is obviously much better than just having the, jumbled mess of numbers that we saw on the last slide, because it enables us to actually start to learn some things about the class and, who did well, who didn't do well, what the average was, and so on. However, we still have to do some thinking here, right? So it would be even better if we could display these data in a way that makes them even easier to understand. To be exact, we can ask for a frequency graph. So instead of using a table with a bunch of numbers in it, we can actually visualize these data in a graph. The way that a frequency graph works is it uses a bar for each score to show how many people got each score. So this is an example of a frequency graph from SPSS that displays the same data that were shown on the previous slide. Note that on the x-axis down here, every exam score gets its own bar. So there's a bar for 77, a bar for 78, a bar for 79, a bar for 80, and so on. The height of that bar tells us how many students got that particular grade. So again, you'll see that 2 people got 77s, 1 person got a 78, 2 people got 79s, 4 people got 85s, for example, and then all the way up to 1 person who got a 98. The reason this is important is that for the rest of today's video and into next week, we're going to start talking about a concept called the distribution. The distribution is really just a fancy word for the overall shape of the graph. So if you want to think about the distribution, you kind of step back from the graph and maybe squint a little bit and imagine a line that connects the tops of the bars of all the graphs. So if we were to do that, we would have a line that kind of looks like this and then goes up in the middle and then goes down once we get above, 93 or 94, telling us that there were a lot of people who got grades in the B to A minus range, some people that got, high C's, low B's, and few people that got high A's for people who were 40 years old. Now, rather than looking at each individual little tiny bar, if you kind of step back and you look at the overall pattern or the overall distribution of the graph, what you'll see is there's kind of a spike when kids are really young, right? So when kids are 1, 2, 3 years old, there are more frequent calls to ambulances, probably because, these are young kids that might have health problems, might be getting into things or eating things that they're not supposed to be getting into, that then, the parents or caretaker calls the hospital who sends an ambulance. But then once kids get into school age, around say age 5, there's a drop off in ambulance calls, which again kind of makes sense, right? By that time, kids are probably not putting things in their mouths or eating things that they're not supposed to, but they're also probably under more constant supervision, right? They're at school or they're at daycare or whatever, so there are probably fewer emergencies. Then there's another spike in the graph, right around, say, age 15 or 16, which kind of makes some sense. What are people doing at that point in their lives? Well, first off, they're getting their licenses, so they might be getting in car accidents that warrant ambulance calls. Secondly, they're going off to college where they have less supervision and might be, getting themselves into some sticky situations, maybe drinking too much or whatever it might be, that again might require an ambulance call. So we see this spike right around college age, between say 17 and 22. The curve then goes back down again, right? And then it slowly goes back up pretty steadily from age 40 to say age about 75. That makes sense, right? The older you get, the more health problems you have, the more likely you're going to need an ambulance. We then see a pretty sharp spike around age 80, when people are particularly elderly, particularly frail, right? Maybe having falls or other accidents. Those are the people that are needing ambulance calls the most. So this is what I mean when I say the word distribution, right? It's one thing to look at each individual bar of the graph. But if you take a step back and you look at the overall shape of the graph, the overall shape of the bars, again, you can kind of imagine an imaginary line that connects the tops of all of the bars. What you're going to see is some peaks and some valleys. That's what the distribution refers to. And in a few weeks, or in less than that actually, we're going to talk about different types of distributions and what sorts of variables might lend themselves to different shaped distributions. Now, when we're using graphs to display our data, we can use one of two types of graphs. On the next slide, we will see that for continuous variables, we're going to use a type of graph called a histogram, whereas for categorical variables, we're going to use a type of graph called a bar chart. Now, the example we've been talking about in this video, the example of 50 exam scores is a continuous variable, so we're going to use a histogram to display those data. There are two types of histograms that we can use, and either type we can get from SPSS. The type that we saw 2 slides ago is called an ungrouped histogram. What makes it an ungrouped histogram is every score gets its own individual bar. So what we end up with is a histogram that consists of a whole bunch of really skinny bars. There's a bar for 77, a bar for 78, a bar for 79, a bar for 80, and so on. The alternative is that we can group some of these bars together, in which case we end up with something called a grouped histogram. Now, on this graph, rather than each bar indicating one individual score, now in a grouped histogram, each bar represents a range of scores. For example, in the ungrouped histogram, we can see that 2 people got 77s, 1 person got a 78, and 2 people got 79s, because each of those scores has its own separate bar. On the grouped histogram, anybody who got a score between 75 and 80 is lumped into the same group. So those 5 people who got 77, 78, and 79, those people all get lumped together in the grouped histogram. And we just have one single bar which stretches from 75 to 80, and the fact that it's 5 units tall tells us that 5 people in the class got a score that was somewhere in that range. Now there's a pretty obvious trade-off here, right? The graph on the left, the ungrouped histogram, gives us more detailed information. For any individual score, we know exactly how many people got exactly that score. However, the graph is also kind of cluttered, right? So the grouped histogram on the right is a lot more visually appealing. There's fewer bars. It's a lot easier for us to read. However, it also sacrifices some information. Take this leftmost bar, for example. All we know is that 5 people got scores somewhere between 75 and 80. We don't know what their actual scores were. Maybe all 5 of them got 75s. Maybe all 5 of them got 79s. Maybe there were 2 76s and 3 78s. We have no idea just from looking at this graph. But again, it's a lot easier for us to digest. So depending on what your goals are, an ungrouped histogram or a grouped histogram might suit your needs better. Whoops. And 12 people who had brown eyes. And again, we can tell that from the height of each bar. So here's an example of a bar graph that shows the categorical variable of how people like their steak prepared. So what we have here are the results of a survey of 432 people. So we would say N equals 432 here. All of these people do in fact eat red meat, so there's no vegetarians or other folks included in this sample. And all they've done here is they've taken the bar graph and turned it sideways. So now the length of each bar tells us what percentage of the people in the sample, when asked the question, said that they liked their steak prepared that way. So 38% of people who were surveyed said, I like my steak medium rare. 5% said they like their steak rare, and so on. This is a categorical variable, to be exact, an ordinal variable, which is why we have to use a bar graph to display these data. And notice that the bars are not touching each other as well they shouldn't. Just to hammer this point home about the difference between histograms and bar graphs, I dug up this old Reddit post from a few years ago. You'll notice the title of the post is, I made a histogram of my wife's shoes versus mine and I ran out of house. And this is a picture of the supposed histogram that this guy made. And you'll see on the left here is all of his wife's shoes lined up in a row. And on the right are all of his shoes lined up in a row. And the point he's trying to make is that his wife has many more shoes, so his, her bar of shoes is much taller than his bar of shoes. However, some smartass in the comments, and I applaud this person, said, that's actually a bar chart. You and your wife's shoes are categorical data, but histograms display continuous data. So how can we actually use SPSS to generate a frequency graph? Again, for the purposes of this example, I'm using the class survey data from my old fall 2019 class, which, as a reminder, you can find on our course website under SPSS data files. In the top left here, you can see that the name of the file is 212survey-f19.sav, and if you've been able to download and install SPSS on your computer, you should be able to just click on that file and open it up as you'd open up any other file. The screenshot you see here shows variable view. You'll remember that variable view gives us a list of all of the variables that we have in our data file. So in other words, a list of all the questions that were on our survey. For each variable or question, we have a name that is short and descriptive. We also have a label that tells us a more detail about what that question asked. Over here under measure, all the way on the right, it tells us whether that variable is nominal, ordinal, or scale. And if it is a categorical variable, under labels here in the middle, we have designated a number to correspond to each category. So for example, variable number 11, which is called handed, that tells us whether each person in the class was right-handed or left-handed. If they were right-handed, they got a 0. And if we were to click here, it would tell us that if they were left-handed, they got a 1 for that variable. Another reminder too, as I mentioned in the last video, in the View menu at the top, make sure that the View Value Labels button is checked so that you don't have to remember which numbers correspond to which categories. Instead, SPSS will just show you the names of the categories in DataView. Anyway, to get a frequency graph, here's what we're going to do. we're going to go to Analyze Descriptive Statistics. When we hover over Descriptive Statistics, we will see a bunch more options pop up. We're going to select the first one called Frequencies. When we click on Frequencies, this is the window that's going to pop up. Get used to seeing this because most of the pop-up windows in SPSS look like this one. And by that I mean that on the left side we have a list of every single variable in our data file. We have age, sex, class year, do you live on or off campus, how tall are you, do you own a pet, what's your eye color, and so on. What we're going to do is we're going to select whatever variable we're interested in testing, and we're going to use this little arrow button in the middle to move that variable from the list on the left over to this empty box on the right. If we do that and we click OK, what we will get is a frequency table, like the one that we saw several slides ago, where for every possible score, SPSS tells us how many people got that score, or how many people fall into that category. Let's say we also want to get a graph in addition to our table. In that case, under Charts, we would click the Charts button. It gives us a few options. If we're working with a categorical variable, we could select a bar chart and click Continue. If we're working with a continuous variable, we could select histogram and then click Continue. Again, make sure you select the right type of graph depending on what kind of variable you're working with. In this case, we have a question that asks how many siblings a person has. So on the left-hand side, we're going to scroll down until we find that variable that tells us for each person how many siblings they have. We're going to highlight that variable from the list on the left, and we're going to click the arrow button in the middle to move it over to the right-hand side, that empty box that says Variables. And then in the Charts menu, we're going to click the button for histogram because we know that number of siblings is a number, so it's a continuous variable. So we would like SPSS to give us both a frequency table and also a histogram that displays how many siblings the people in this class had. So there is that information. And when you do this, this information will pop up in a new window that's called the Output window in SPSS. First, you'll see the frequency table on the left, or something that looks very similar to it. That tells us that there were 72 total people in the class. So at the very bottom where it says total, you'll see there were 72 total people. And then above that, for each number of siblings, we have the number of people in the class who have that number of siblings. So there were 3 people in our class who have no siblings, in other words, are only children. There were 29 people in the class who have only 1 sibling, 17 people who have 2 siblings, etc., etc., all the way up to there were 2 people in the class who actually have 7 siblings. When I was talking about frequency tables before, I also mentioned that we can calculate the percentage of people that fall into each group or have each score. Fortunately, SPSS will do that for us. So if you look where it says percent, those numbers all add up to 100. So we can say, for example, that 4.2% of the people in the class have no siblings. 40.3% of people in the class have only 1 sibling, and so on and so on, all the way up to 2.8% of people in the class who had 7 siblings. Now, if we want to make it even easier for ourselves, we can look over at the frequency graph, the histogram. Notice in SPSS the bars aren't quite touching each other, but they're awfully close. If you're ever drawing a histogram in here, please make sure that the bars do indeed touch each other. But again, all this graph is doing is it's taking the information from the frequency table on the left and it's showing it visually in terms of how tall each bar is. So only 3 people have 0 siblings, so this first bar is only 3 units tall. 29 people have 1 sibling, so this next bar is the tallest bar out of the bunch. There was no one actually who had 5 siblings, so there's a gap in our histogram there because there's no one to go in that, that score. But there were 2 people who had 6 siblings and 2 people who had 7, so we have a short bar for 6 and a short bar for 7. Again, think about this graph in terms of the distribution, right? Imagine a line that connects the top of these graphs. So we've got a pretty sharp peak at one sibling, right? One sibling was very common. And then the graph sort of tapers off gradually all the way out to the people who had an unusually high number of siblings, 6 or 7. That's it for this video. When I see you all in class next Monday, we are going to talk about a special type of histogram, a special type of distribution called the normal distribution. Some of you may be familiar with this, but even if you're not, no worries. You will be familiar with this very soon, and we will talk about why the normal distribution is an important concept in statistics.